Hi everybody, I'm André Bottaro, so I'm responsible for the digital home research program in the Orange Labs, and I am also the leader of the collaborative project in France called Open the Box, and I will have the pleasure with Fred Rivard from I2T, so the CEO of I2T, to present the vision of Open the Box and some results that we have with this French collaborative project that has begun at the beginning of 2012. We'll have the pleasure to present to you also a demonstration after an introduction here with one of the demonstration coming from Open the Box project, showing that we are working on open APIs for the smart home. So opening APIs on a box to open an execution environment for all smart home applications coming from any partner. There will be a focus on open APIs on the box, thanks to the presentation of Fred Rivard. But Open the Box has also some open APIs on the cloud for other partners to deploy applications, to remotely manage their applications, their devices, and also interact with applications from remotely. We will see, especially in the demonstration, contributions from other partners, especially Bouygues Telecom, who is a partner with us on the demonstration, Delta D'Or, and Igenco. So, as a summary, we see here in the IoT and especially in the smart home a new world of applications about to emerge thanks to the growing variety of devices becoming available in the home. To accelerate the service delivery, we are convinced, and I am convinced personally, that we have to open this mutualized infrastructure, and a telecom infrastructure, to any partner, any developer, even in the long term, to deploy applications on this common infrastructure. Today, we see that many partners have first products, and they are making the first step with some open APIs on an infrastructure. There are some challenges that remain, and Open the Box is a project that addresses some remaining challenges. We'll see that. Especially, we'll see that with a presentation from Fred Rivard, who is making with I2T a very low footprint execution environment with the OSGI standard. So it is even more low cost, or even with a lower footprint than Concierge or other open source project that have been presented earlier. And we will have a focus on cost and reliability here in a part of the presentation. That's a part of the results of Open the Box. And at the end, we will have this demonstration. So, as you know, smart home is a niche market that is slowly taking off. We see so the smart home as being a set of several application domains. I mentioned 7 here, application domains in the slide. It is about security, energy, comfort, but also elderly care, wellness, multimedia, and games. There is a convergence between the multimedia services that we are already selling on our telecom infrastructure, and the home automation, e-health services that are also coming in the home. And new products emerge. So I have taken some pictures of some things that have been the buzz at the Las Vegas Consumer Electronics Show. Every year there are some new ones. So you can see some things to monitor your your sleep at night, or the first connected toothbrush by Colibri, moisture sensors. If you think about white goods and smart appliances, there is this first connected cooker by Seb. There are also other white goods from other manufacturers. So there are really a lot of connected things and sensors and actuators that are becoming available in the smart home. All the initiatives and the new products that appear show that today the ecosystem is somewhat boiling, and we have to federate this ecosystem to have more service delivery and to deliver this whole vision of the smart home to the user. So I mentioned, of course, traditional business actors with Delta, Schneider, and so on, that are being on this niche market for a long time. But today there are also many more companies in the energy sector or in the telecom sector that are now selling products. In Orange, we will have a product called Smart Home by Orange, called by our CEO some months ago, and that will be released this year. So in order for this vision to happen, I am convinced that we have to mutualize the telecom infrastructure and open this telecom infrastructure to a set of partners, and in the long term to any partner. And in Open the Box collaborative project, we have worked a long time on the use cases, and thanks to this analysis, this use case analysis, we have written a role model with 9 actors interacting with a shared system. So the shared system is based on an infrastructure with 2 pillars. With the first pillar is the embedded environment that is in a box, which could be a gateway or an over-the-top box. And the other pillar is one platform in the cloud in order to remotely manage applications that are embedded or device and actuators in the home. And this management is offered to any third-party player that could manage, interact with the applications from remotely or from locally in the box with deployed embedded applications. In this picture, we see especially that we have separated some roles in order for a wide set of business models to emerge. So we have especially separated the role of the internet service provider, the operator of the smart home environment, which is another actor, and a last one, which is the application store manager. So in this picture, we see that the internet service provider has not a central role, and this is a telecom operator that says that. We could sell, of course, quality services related to quality of service, but the main service and the main infrastructure is not related to new services from the internet service provider. Some actors have a central role in the picture. That's the case for the operator of the smart home. So this actor is responsible for certifying the applications that could be deployed, labeling, giving a label to any device that could be connected to the box. He's responsible for giving the right access rights to any actor in the box and in the cloud APIs. So he has a central role in the deployment of applications and the service delivery. There could be one or more application stores, and the role of an application store manager is to simplify the catalog of applications that is presented to the user. So it is simplified according to the devices that are already existing in his network, and the potential devices that could coexist or being interoperable with the system. Then another important hint in this role model is that we have separated. We have to separate the device provider for the service provider in order to avoid service silos, and in order to have to unleash the service delivery. We are convinced that for the system to emerge, devices should be shared by for any for all the services, and service could connect to devices from different manufacturers. So in this vision, there are so the first step is possible immediately for some manufacturers or some telecom operators to deploy such an infrastructure. And in order to be really open to any partner, we have to address some challenges. So there are challenges in the embedded execution environment, and today we will have a focus on robustness and adaptation to constrained devices. That is also getting along with a contribution from OpenTheBox on resource management and on security. And Fred will have some slides about that. And there are also other challenges that will not be presented in the remaining slides. So there are challenges to open the device management platform to any partner, for any partner to administer their devices, their applications, and only the part they have the responsibility for, they have the responsibility. And there are also challenges on the box and the material in order to have to of course integrate the best low-cost protocols and to make them coexist in the platform. So now I give the floor to Fred for a focus on the embedded software platform challenges.
So hello everybody, I'm Fred Rivard, so I'm the CTO of IS2T and also the founder. Thanks André for the presentation. In the OpenTheBox project we had some specification and requirements that came from the use case, and I will provide you some slides about these requirements and how we have implemented these requirements. So basically, the very first important thing is that when you are running a home, let's say home gateway, you should not interfere with the other services, the primary services here, because currently the business model is here, so you have to secure this business model. So adding a new service, this new service should not interfere with the other premium services in home. So that's why we have designed a virtual box here, where the home services of third party can be running on. So in terms of what is services, in terms of marketing for someone that provide a home regulation, for example, I know that you are technical guys, so so you know about OLGI. So a service is in fact a group of bundles. So let's go more into details. So as you can see, sorry, I forgot that this layer, this virtual layer, will control the access from these services to the hardware, and of course the devices that are connected to the hardware. So let's go a bit deeper. We have what we call kernel and feature. So it means that you have the one that provides the ecosystem. We provide some API. So typically Orange will provide some API to define a specific ecosystem. Bouygues another one. And so here you have another kind of hardware supporting another kind of ecosystem. So there is one kernel that control all the access to the hardware, and here you got the services that rely on API, and on top of that there is an OSGI framework to let's say to because the semantic is well known, and group of bundle is notions as something well known too. So what were the requirements? So the requirements were we should be OS agnostic, meaning that any kind of Linux underneath your service should be running the very same way. You should not rely on any kind of OS. Currently, we have put this implementation on VxWorks, Linux, and some funny RTOS, low-level RTOS, like Mecrium, for example, the one from Mecrium. And in terms of execution, we are always trying to reduce the bill of material that is necessary to run these services. So in the open-to-box projects, all the partner wanted to have something that is less than 1 megabyte of flash and 1 megabyte of RAM in order to run into current boxes from the telco guys. So we try to avoid any kind of bloatware. So, as André mentioned it, we had to control the resource access from the services, and try to do a segmentation. Service A could use 30% of the CPU, and the service B 50%, and it should be reliable and secure. So it means that you may really kill a service, meaning that you need to kill threads, you need to be able to kill objects, whatever the current runtime being executed, and of course no backdoor, so no style reference, no zombie thread, etc. So it was quite a bit tricky to do in the virtual application layer, the VM. So the principle is the marketing guys wanted to design a service as a group of bundles. So this is what we have done, and we tag every aspect of what you manipulate. So we tag every object. So an object has an owner, the service. We tag also the code, and of course the threads. And with that, we are able at runtime to know who's looking for a specific resource, and who's consuming some CPU, flash file systems, access to a device. So in terms of arbitration, the kernel is supposed to be secure. So the guys that designed the API for an ecosystem we suppose that it's secure. So you can filter the access to the underneath. And here you can, I know that most of you are writing Java, so here you're allowed to write native code. Whereas in the services where it is completely under the control of the VM, you're not allowed to go and write the native code. So you rely only on the kernel API, so basically the ecosystem you are in, and if you want to talk to another feature, another service, you have to be allowed to do it thanks to a proxy object in the kernel. So everything is controlled by the VM, and you can't escape your service, and there is no backdoor. So in terms of ownership, a type is owned, so it's going to be a bit technical here now. So a type is owned by the service that has loaded the type, so we call the service feature. So you can ask for any object its owner. You can, of course, when you create an object, the owner of the object is the owner of the current execution context. And the current execution context, in fact, it is a thread. So at the beginning, when you create a thread, it starts being owned by the service. And we have rules, basically, when you can enter in kernel mode, and only the kernel code can enter into kernel mode, and then you can do what you want in the kernel mode. If there are some callbacks, typically in OSGI, you can register a service. So it means at some point you will send callbacks for the listener. Then the listener will be grant the ownership of the execution stack. So it means that what you create in the callbacks are owned by the service that is requiring to be called by the callback. So a very fundamental API is you can get the context owner. What are you a feature? Are you executing a service, or are you executing in kernel mode? And the kernel can of course decide. The code of the kernel can decide to enter the kernel mode, and nobody can execute kernel API except the kernel itself. So it's basically a very secure model. It's like an hypervisor. If someone knows about hypervisor, basically we have added an hypervisor into the virtual VM. So how do we generate, let's say, a feature, so a service? It's basically we tag that with a certificate, and so at runtime you can ask the property of your service anywhere. So I will go a bit faster. So the loading is quite straightforward. The bytes of your bundles get linked, and then there is the kernel creates a thread for you, and the link phase is over. And of course, the ownership of the thread is the service itself. Then all the initialization is done in that thread, and there is an entry point that starts all the bundles, and of course this entry point starts all the bundles. It's like an array, start, using the start levels of the different bundles in your service. Unloading is something similar with the fact that we are able to kill everything, and you can really kill threads, whatever the execution steps you are in. So and you can of course garbage collect all the objects, unless you have made a bug into your kernel where you have some pointers from your kernel to objects that are owned by features code. So this is typically a bug of your kernel. So in the OSGI specification, I mean, open the box, use the OSGI. So we have we had to put OSGI on top of the kernel feature semantic, and so just to mention that bundle context access is usually only used by the bundle itself. So it means that if you have a good programming style in OSGI, you will feel very safe using kernel feature 2, because the feature is only the code you can access to within the feature is only the code of the feature itself and the kernel. And of course, everything in terms of exception and in terms of permission you can control. So each time you have a service permission, a file permission, and all the access, go down to the kernel, and you can design the policy of resource access you want. So it's up to you. So in terms of security, you can at runtime do introspection. Who's asking to gain access to a resource? Who's consuming? And so everything is has to be defined by the one that defines the ecosystem. I mean the kernel. So in terms of size, how much is what's the overhead of having such kind of semantics, an hypervisor into virtual machine? So the virtual machine itself is 50K. So it means that we are much less than the 1 megabyte of flash. So it leaves quite a room for the application itself. In terms of RAM, the VM only consumes 1K, and the kernel feature extension is about 10K of flash. So it means that you have a full Java system with a very low footprint. And we have a generic linker, and we are finishing a linker for microcontrollers boxes. So very cost-effective microcontrollers, like I have one here. It's like the Sony watch. So here it's running a Cortex M3. So everything is available on such kind of devices. So let's jump to the demo. So the demo, I will start from the bottom. So what kind of devices? We have a door. I mean something that checks if it's open. We have a light, and what we have left. We have only two for the demo. The devices are using two different radio systems. So it means that you can have any kind of devices from any provider. At the infrastructure level, from the telecom guys, we will be using two boxes. It means that these guys are decoupled from the other one. The same infrastructure is running on both of the boxes, and on top of that, we use a commercial service from Igenco. Maybe some of you know Direct Energy. So it's the service of Igenco underneath. So the demo will well, Frederick, I can maybe you can.
Okay, so maybe we can switch from. Okay, so if you remember the previous slide, on top of the slide there was a Igenco service provider which has been developed on kernel APIs and has been installed on Java Virtual Machine on both boxes, the Live box from Orange and the B box from Bouygues Telecom, and this service has been insulated over kernel and features. And this service is very basic. You can manage your device, and you can connect the cloud, Igenco cloud, and here you have the web portal, the counterpart from the internet to manage the service that has been downloaded on the box. So you can see what is connected. For now, all the devices are not connected, but you can see you have, it's in French, sorry, but you can see you have a door sensor connected and a Zigbee plug here.
Yes, when we say we deploy the service over KF, we deploy the service, in fact, on OSGI over KF. For us, it's one same thing, in fact, in terms of semantic.
So if you are the end customer, you can access to your device, and for example, you can manage manually your device by here turn on the light or turn off. Sorry, because the mobile connection is very slow. Normally it should work.
We are using a Wi-Fi over 3G connection.
Yes. So maybe it's disconnected. Okay.
So
very quick.
Thank you, the SIM card, the 3G connection.
So if I can just, maybe I can check here on another web page. Okay. You can also see from the web portal the energy that has been consumed. Here you can see that the revolving light has 18 watts, and now I can try to turn on off. Maybe the connection will be faster. Okay, and I have also designed a basic scenario. When I open the door, the revolving light is turned on, and 15 seconds after I've been closed the door, the revolving light is turned off. So and we can see in the protection submenu the logs. So you can see, for example, that someone has opened your door at home at 11:23. No, now
the scenario is running on the box, not in the cloud.
Yes, scenario is running on the box. So now I have my radio dongles connected through a USB hub connected to the B box, and now I can dynamically unplug. And so my objects are no more connected, and if I refresh the web portal, I should see that the box is no more connected. So check for the refresh. Connection is very slow. Okay, so here you can see the box is no more connected, and then you can imagine the customer, the end customer, has moved to Orange Livebox. So it does not have to reappear all its devices connected to the USB. It just have to connect his new USB dongles through the new box, and the service is downloading again. The Eclipse service is downloading again. The Zigbee devices are initialized, and now I can refresh the web page, and it should be okay. I can see that I have the box connected. So I can, for example, do exactly the same things. Open on the light. Still the connection. Open on the light, and then I can turn on exactly, see, for example, the consumption. And I have just moved dynamically from one hardware box to another, and exactly the same service provider, Eclipse, is running exactly the same on both boxes.
In fact, the Eclipse service does not know the infrastructure it is running on, and it just don't know what kind of devices. Just it uses APIs and a generic infrastructure.
It's okay.
Yeah, you can switch maybe the presentation. So you have seen in this presentation, beyond the case that Bouygues Telecom client has moved to Orange, which is sort of important here. But since I have Bouygues Telecom in the room, I should we could also make the demonstration work in the reverse way. Sorry. Yep, sorry. And what? Sorry. Yeah, and just to conclude, yeah, you have seen here that we are really about openness, and we are really having this vision of open APIs that we could also share with competitors like Bouygues Telecom, but also other operators. At the European level, we are also working in the Home Gateway initiative with other telecom operators and other partners to open those APIs. And here in Open the Box, we have shown also that the OSGI framework could be also embedded in very tiny boxes. That is not really shown in the demo, but because the boxes are somewhat have some performance, but we could also have this I2T OSGI gateway in a very small devices. And above this embedded JVM, 50Ks. We have Java libraries and OSGI running above that. That takes, with libraries and the OSGI, I think some hundreds of Ks.
Yes, if you need a regular Java SE file system, for example, networks and stuff like that, we have a library called Eclipse that provides such kind of API. And then it's up to you in terms of how much hardware you have in your hand to run this implementation of API and the libraries.
And in the Open the Box project, we have this demonstration and this result, and we have also other results about these open APIs that are embedded in a box and also on the cloud provided by the smart operator on a cloud platform. And the first objective of Open the Box since 2012. It was to integrate and create a standard execution environment, so in the cloud and in the box. And we have also this objective to create a dynamic market of applications and to run this role model with all the actors on a demonstration. So here you have seen that there are at least 5 contributors to the demonstration: Bouygues Telecom, Eclipse, Deltador, ASQRT, Bouygues Telecom, Orange. And the final objective is to publish this model and a set of APIs to the industry. So we have the previous presentations have talked a lot about open source and a little part of on standardization. So we do both in this project. We will communicate more on open source part of the project. We have at least one open source brick that is a device management client that is in the box with the TR69 standard from the Broadband Forum. We will, I think, push also something on Zigbee, a Zigbee driver. We will push other things, a Notion driver, a Notion-based driver that we are also standardizing at the OSGI Alliance. We are also standardizing something about resource management, and ISQRT has already a part of these APIs in the box. So we will communicate in the following months about other results and other bricks that could be open source or standardized. Thank you very much.
Any questions?
In the demo, the boxes are self-discovering the things, the objects. How does it work? Or you need to pre-configure at least the type of objects that come?
In the demo, we have at least 2 dongles that are USB dongles that are connected to devices. And to make the demo fast, we have a pairing that is already made between the dongles and the devices. So that is why when we switch the boxes, the pairing is not made. It is pre-made.
The pairing
it is already it is deployed once again on the box, and then it could be connected to the devices again.
Yeah, the pairing is saved in the cloud, and so when we switch, you ask for the pairing. So the pairing is downloaded. It appears the devices, and then the service can start again and all the stacks, and then.
Okay, but the very first time when you initiate the system, you need to pre-configure the devices, or the boxes are able to discover those devices.
It's like regular devices. You have to pair them somehow.
It depends on the protocols, but with Zigbee, of course, you can. There is a automatic discovery made with that, and then when it is discovered, you have Java objects that are registered as OSGI services on the gateway, and then the applications react to these services and interact with those devices through those Java objects. And there is also Advision, I think, on.
Yes, the DOS sensor is from Advision, which is a Castorama, if you know.
Yeah, Bliss, the Bliss brand.
So the Bliss products.
Okay, is that answering your question?
question goes to your demo. You have written a program. What kind of language did you use for programming?
Oh, we can ask to Ijenko exactly, but in terms of program, I mean the HMI. Maybe you can switch on. I don't know exactly the underlying of the Ijenko service, but I can show you the HMI from the user point of view. For example, here you have a program. You can create a new program here, and then you can. I think you can. There are some predefined programs, and you can also instantiate the predefined scenario with the device you have plug on. For example, here you have something you can turn off some device, and you can here select with the list of devices that are actually connected.
So on the box, the programming language is Java and OSGI, but they also have a rule engine and
yes, there's a rule engine from Ijenko, proprietary from Ijenko. I don't know exactly which rule engine is running.
Yes, you mentioned you avoid stale references a couple of times, and then I saw that a feature is a set of bundles, but then the feature only sees its own services, right? So can features communicate between themselves?
Yes, and there's a control of the kernel. If the kernel didn't provide you this, let's say, facility, then you will not be able. You can't put a pointer from one object owned by a feature to another one. So it's under the control of the kernel.
And how do objects created from one feature?
They are owned by this feature.
If I want to share an object with another feature, I pass it through the kernel, and then, or how does that work?
Yes, somehow, and I say somehow because you need to ask the guy that has created the ecosystem from the kernel to allow you to do that. Maybe you are not allowed to do that, and most business case we saw, you're not allowed to do it because it's too dangerous. In fact, you don't want to rely on another guy for your service. So it's a matter of let's say here in this demonstration, it's a matter of did Bouygues or Orange, for example, give you the ability to do it, and how did they provide you the API to do it? It's that choice.
So if I decide to share an object,
you are allowed to do it only if the ecosystem manager allow you to share it to another service.
Today, on the first step to open an embedded framework to several partners, it sounds that the market doesn't expect that partners talk between each other. So in the first step of the model, we are comfortable with features being group of bundles and not interacting with each other. And we are also thinking about maybe next steps where some partners are also a part of the middleware that are shared by others, and then there are some mechanisms to apply with a more secure thing with the kernel.
You guys specify very clearly, and your stale references are like inside of a feature. I can program and have stale references among the bundles.
Yes, you can shoot your foot if you want. And
the feature is very isolated.
Exactly. In terms of thread, code, and object.
Okay, thank you. Thank you for the demo.
Thank you very much.